A very common problem, even in the peer-reviewed literature, is non-independence of observations. All statistics courses state that observations or residuals should be independent. But because assuring independence is a matter of methodology rather than statistics, most statistics courses do not elaborate on the subject. However, if observations are not independent, p-values will become worthless. So, even though this is a series about statistics, I will in this video discuss a number of examples of non-independence and hope that you will then recognize possible non-independence in your own projects. We will look at some common problems: shared history, pseudo-replication, technical dependence, and repeated measurements. What is independence? It means that the outcome of measurement on one unit is not related to that of another unit. Suppose my units are dice. The outcome of a throw with one die is normally not dependent on the throw with the other one. But most experiments do not use dice, but maybe persons. And a person's height or any other biological or cultural outcome will on average be more like her sisters than like a total stranger's. Sisters or other family members are not independent, whether they are people, mice or seeds. Solution: take one per family, or average values per family. A specific example: you transfect cells with some construct, let them grow to colonies, and then do some experiments with cells from the colonies. Separate cells from the same colony are not independent, so only a colony with an independent transfection is an experimental unit. These are examples of pseudo-replication, but there are many other ways to get pseudo-replication. A population or a sample is made up of units, and treatments must be randomly assigned to units. This means that if you apply a treatment to a bunch of things together, they are a bunch and not separate units. If you apply a treatment to a whole pen of chickens, aquarium of fish, or field of lettuce plants at once, the pen, the aquarium, or the field becomes the unit, and you should average your measurements of chickens, fish, or plants to get one value per unit. This has enormous effects on your power. Well, actually, there are methods to include the individual measurements, but in most situations, taking the average will result in the same p-value. Averaging the values per unit can be a real bummer. You measured 48 lettuce plants, and now you are left with only 2 values per treatment, because every treatment was applied to 2 fields only. So think about this before you act. Technical dependence is caused when technical equipment can have an effect on the measurement. In the lab, this is quite common. A 96 Wells plate in a PCR machine often replicates worse on the edges. If one treatment, for example the controls, occurs more often on the edges, differences between cases and controls can result from their place on the plate instead of something else. Same goes for ELISA or many other equipment. Differences in measurement outcomes occur over time or place, and therefore you should randomize your samples before measuring them. The final example is not so bad. Can even be advantageous when dealt with properly. In many experiments, the same individual is measured multiple times, either just to get measurements after 1, 3, and 6 weeks, or the same volunteer is used in multiple treatments. If you are using the same person, plant, or mouse multiple times to measure the same variable, the outcomes are not independent. A plant that is small in week 1 is likely to be still small in week 3. However, As long as this is set up properly, this situation can be analyzed using blocks or repeated measurements analysis without loss of power, maybe even gain of power. So, independence is very important, and lack of independence is not rare in experiments or also in observational studies. Beware of subjects that share genetics, unless you control for that, or that share some history. Remember that treatments must be applied to units independently, and randomize the order of measurement.